Good morning all, and thank you for joining us today for our webinar where we're looking at carbon capture and storage, and in particular the role that standards can play to support the rollout and scale up of this technology. I'm Seb van Dort, BSI's Director for Energy and Sustainability, and it's great to see so many of you here today. I'm excited about the discussions we have in store. Carbon capture and storage, or CCS as we'll probably call it going forward, is widely recognised as an essential technology for achieving net zero targets. As industries worldwide grapple with the decarbonising hard-to-abate sectors such as cement, steel and chemicals, CCS offers one of the few viable pathways to significantly reduce emissions and contribute meaningfully to global climate change targets. In today's conversations, we delve into the role that CCS plays, how standards can support this and potentially accelerate the deployment of CCS. We believe that standards are crucial to provide the confidence and clarity that businesses, policymakers and investors need to move forward at scale. So this webinar aims to foster dialogue, encourage collaboration and highlight some of the great work that's going on in this space. We have an outstanding panel of experts who can guide us through this interesting topic and share their experiences and insights on the role that CCS plays. So let me briefly talk you through who our panel of experts are. We've got Andy Brown, who's the Director of Engineering for Progressive Energy. Andy has been working with low carbon technologies for over 30 years and was a founding director of Progressive Energy in 1998. At the inception of the HyNet project, of which the decarbonising of the Stanlow refinery is a part, Andy led the engineering team that developed the project, and he maintains an active interest in the whole value chain. He's the UK nominated expert in CO2 transportation as part of ISO TC 265. And he led the UK delegation for the development of CEN TC 474, a new technical committee at CEN looking at CCUS. Andy is the co-chair for the technical working group of the Carbon Capture and Storage Association, and he chairs the working group responsible for all CCS work at the Energy Institute. We have Ben Rowton. Ben is the Strategic Business Development Manager for the Energy and Environment sector at NPL, the National Physical Laboratory, who are a key part of the broader quality infrastructure. Ben is responsible for shaping the organization's clean technology strategy, prioritizing investment into new capabilities, and overseeing a portfolio of public and private sector projects. His work focuses on accelerating the development and deployment of emerging technologies such as batteries, carbon capture and storage, hydrogen, and smart grids through the creation of robust measurement standards and test methods. He works closely with government, industry, and international partners to support innovation, standardization, and support technology commercialization. He's particularly passionate about bridging the gap between industry and academia and the critical role that pre-normative research and the national quality infrastructure plays in enabling clean growth. And finally, we have Beth Hebditch. Beth is the head of UK policy at the Carbon Capture and Storage Association, and she focuses on the development of CCUS policy in the UK. And she's responsible for the coordination of the CCSA's regulation and policy forum. Her particular policy areas of focus include power, CCS and industrial carbon capture and storage. Beth joined the CCSA in 2023 with a background in geoscience and energy, having previously worked as a consultant across European power, gas, LNG and carbon markets. Now, before I'll hand over to our speakers, I'll give a brief overview of what we have in store, who we are as BSI and what we do, and then I'll hand over to our speakers. So let me introduce who we are. We are the UK's national standards body. We are independent and apolitical, but we operate in the national interest. What that means is we are independent from government, but we're also independent from industry and a not-for-profit, or as our chief exec likes to call it, a profit for purpose. What that means is that all the profit that we generate goes back into the company, not to external stakeholders. And that profit is used to support with our purpose of standards and standardization. When we create standards, all our standards are created and led by stakeholders, and all our standards go through a rigorous consensus and consultation process, and that's how they get their legitimacy. I and my colleagues strongly believe that standards play a key role in helping to support and deliver on government policy objectives. And through that consultation and consensus process that is stakeholder-led, we believe that standards get their legitimacy and reputations. All our decisions that we make as a national standards body and as a business are in this context. Next slide, please, Doris. So As the UK's national standards body, we support UK industry and UK government with national standardisation needs, but we also support the UK and represent the UK voice into international standards making. So we are part of CEN, CENELEC, ITU, ETSI, IEC, and ISO. And so we put the UK voice forward into international standards making. Next slide, please. So carbon capture and storage is one of the key technologies that can enable large-scale, cost-effective mitigation of CO2 emissions within industry and sectors that are difficult to transition over. In the UK, we have an immense geographic capacity for carbon storage, and I think it's approximated to be 78 gigatons of carbon that can be stored. We at the BSI have a technical committee, which is PSC 265, which looks at this. This committee is responsible for articulating the UK's voice and position into European and international standards making, in particular liaising with the technical committees ISO TC 265 and CEN TC 474. Now, there is a huge opportunity, but there's an interesting sort of element that had happened probably about 3-4 years ago, where we heard a lot about the need for standardization, but we didn't see that much action in this space. And so there's a few things that we did. My role is to sort of set the strategy with our team. And one of the things that we did, we put PSC 265 under active management. And before that, it was not under active management, and it sort of managed itself. And so we really tried to look at what we can do there. Next slide, please, Doris. But we still found that despite that there was still some work lacking, and we really felt we needed to get the industry voice forward. So there's a project that we did that I'm particularly proud of, where we decided to self-fund, and then it took a while to get these sort of internal funding, but we decided to self-fund a research report. We believe that, you know, we convene the experts. We are not the experts, but we convene the experts who can put the industry voice forward. So recognizing this unique position, we went to the Department for Energy Security and Net Zero to propose this research project that we would fund, where we would create a research report that would advise government. Now, we aim to have a comprehensive review of both the formal international standards and also the industry standards, because we felt it was really important to get the practical industry standards to ensure that our research was grounded in real world application. We made sure and wanted to make sure that this was industry led. So it's very important for us to have the voice of industry saying to government, this is what we need. And we worked closely with technical experts to do this. And you know, many thanks goes out to Andy, who will talk more about this report. But the end result is that we developed a forward-thinking roadmap for standardization, which captures this industry expertise, but also the view from stakeholders. And we presented this roadmap to DESNES, and it was very well received. Next slide, please. So on the back of that, we are starting to do more work in this space, but also since we started the research report, there has been quite a bit of change. We had a change of government. Labour came into power, and they have committed to the energy transition. They promised to work with the private sector, and they make the big statement that they want to double onshore wind, triple solar power, and quadruple offshore wind by 2030. They also made it clear that they want to invest in emerging technologies such as hydrogen, but also energy storage and carbon capture and storage in this context. There was recently a multi-year spend. There was recently the multi-year spending review, which recommitted the 21.7 billion to CCUS over 25 years. Government also signalled the intent to follow through on the Track 2 Viking and Acorn CCUS clusters, though details there have been not fully clear. But these projects also aim to anchor heavy industry in regions like Merseyside, Teesside, Humber, and Aberdeenshire, really looking to support jobs, skills, and local growth. So the spending review confirmed funding for the Aberdeenshire carbon capture project. So I'm sure that the experts on the call can give us a little bit more detail on that. Obviously, it was only last week, but it is very encouraging. Now, as I said, we are very proud of the work that we've done on this roadmap. We encourage you to read this roadmap. There's a QR code there. I'm sure we can put a link to the report as well in the chat, and we encourage you to read it and share it and give us your comments. Now, I think with that, that's probably more than enough from me. So let me welcome the first speaker, Andy Brown. Can I ask you to turn on your camera? And just to confirm, Andy is the Director for Engineering at Progressive Energy, who led a lot of the technical work on this report. Andy, can I hand over to you there?
Thank you for that introduction, Seb. Yes, indeed. We were privileged for BSI to contact Progressive Energy and to ask me to look into this. It was an exciting adventure for me because I'd never paid that much attention to standards before. But over the course of the exercise, I came to realize just how important standards were. So I'm sharing with you today with a degree of passion. This was more than a job. This was something that has changed my thinking in terms of carbon capture and storage. So 4 main pivots for my presentation with you today. We'll have a brief introduction. We'll talk a little bit about the process and then the reporting, and then we'll have a quick look to see how the report has been received and what's happened as a result already, but I'm sure there's more to follow. So if we move on to the next slide, please. So, a bit of background here. There are more than a dozen CCS projects under development in the UK. That is projected to store something over 70 million tonnes a year of carbon dioxide. We talk about storing carbon, but of course carbon is a solid element found as diamond or charcoal or graphite or whatever. We're actually storing carbon dioxide, but we shorten that to storing carbon. I'd just like to make the differentiation between carbon and carbon dioxide, because we're not actually storing carbon, we store it in its oxide form. Next slide, please. So, sorry, can you go back to back one? Okay, back another one, that's it. It's a reasonable question to ask, are there standards in place to support these new developments? Now, it's interesting that it's not as if the UK has just invented carbon dioxide capture and storage for these projects. In fact, there are projects all over the world of one sort or another which have been putting CO2 underground. So why are we looking now to see if there are standards? And the answer is, well, as said, there is no formal mechanism that set out at the beginning of this industry to develop standards. So we set out to answer the question. The answer was probably not, but we need to find out. And that was the first part of this exercise. Next slide, please. So, as Seb said, the objectives was to provide a comprehensive overview of the whole CCS standards landscape. That's quite a big elephant to swallow. So it was done by compiling, there was detailed data analysis of the standards, both those that are already published and those that are currently in development. And we also set out to engage with stakeholders as much as we could. Next click. It was also to identify what the gaps were as much as we could, and what are the priority areas that we need to give some attention to, because our expectation is that there would be a lot of gaps, but not all the plugging of those gaps wasn't all of the same priority. So that we can plan in some work, we wanted to look at what the strategy should be forwards. Next slide, please. We want to provide, it's okay, we want to provide a resource for the global CCS industry to use. So although there's quite a lot of focus on BSI, the idea is that this would be something that would have an application way outside of the UK for the benefit of the industry as a whole. Okay, next slide, please. So we started off with phase one here, defining what needs to be done. Next click. BSI decided on keywords. Now, when standards are issued as part of the discipline, there's a set of keywords, and we used those as the criteria, or BSI, this is before I got to it, used those as if you want to doing a coarse sort to find out which ones were relevant. And this is quite a big exercise. Next slide. So they looked at them in two ways. Along the x-axis, we looked along the value chain, capture, transport, storage, and then there's a whole also rounds of generic standards. And on the y-axis here, there was a set of themes. And where the themes and the stages crossed, then that was, if you want, a hit. And that indicated that there was something worth looking at. Also indicated where they didn't hit, there was the possibility there that we needed to, that was a gap that needed to be filled. And you can see that we looked at an awful lot of documents. About 62,000 documents were searched electronically to create this matrix. And once the matrix was created, we needed to then look at the what we'd found and start to evaluate them. And that's where I was privileged to be called in to help. If we go into the next slide, please. Just click again. Okay, and this is the initial screening stage. What we needed to do here was to separate existing knowledge. Well, what we needed to do was look at all these crossovers. Some of them we were able to say, well, I'm familiar with that standard. I know it does, or I know it doesn't address CCS issues. For some of the standards, it was sufficient to dig into them and to read the summary text, because each standard will normally have a section in it that says what this refers to and what this excludes. And for some of them, it wasn't clear from that, and we had to dig into the standard and read the actual text. Out of that, I can tell you that there were a lot of these. And from the next slide, we separated them into the ones that were highly relevant. Those are standards that are directly applicable to carbon capture and storage. There was another section, the amber category, which were the ones that mentions the CCS, but it's not the focus of the standard. The blue ones were standards that definitely needed review. And there was a whole lot that we could discard because although they mention carbon dioxide, the context was wrong. So use of carbon dioxide in fire extinguishers is a good one to give as an example of something that we discarded. Just click again. And that comes up with the numbers of standards that we needed to dig into. Next slide, please. After that, we did what we called a final relevancy review, which seemed sensible having dug through quite so much information. And what we did for this, next slide please, is we did two things. Firstly, we offered the results to the technical working group from the Carbon Capture and Storage Association. Now, this is, if you want, it's the beating heart of the UK carbon capture and storage industry from a technical perspective. It's quite a large group, and I'm sure Beth will tell us more later, but it's the way to find out what is going on the ground with regards to carbon capture and storage in the UK. And the second thing that we did is we picked a small number of people who were active in the area, some people who were, as it were, actually doing this stuff. And we captured it, we asked people along the capture, transport and storage parts of the value chain. So on the capture one, these were people who are actually doing stuff today for carbon capture and storage. And that was SR, NPL and Wood Group. And for the transportation section, we talked to Worley, who are consultants, Alderley Group, who were actually designing CO2 metering equipment, and Murphy, who of course many of you will know are pipeline construction people. Then for storage, we talked to Storiga, who've got a lot of expertise subsurface, the North Sea Transitional Authority, who are of course the authority out there, and TUV-SUD, National Engineering Laboratory as well, who do a lot of the testing work. So we felt that given that we didn't want to interview hundreds of people, that was a pretty good cross-section. We also talked to the Environment Agency, the Health and Safety Executive, and Safe Limited. Safe Limited have been working with my company, Progressive Energy, on the HyNet project. And I've been impressed with the breadth of their knowledge when it comes to CO2 transportation. So those are the interviews, and we took their conclusions and their experience into consideration when we were compiling the report. Next slide, please. Comes to the exciting bit of the analysis and reporting. Now, we wanted this report to be accessible to a wide range of people, some of whom will be intimately familiar with carbon capture and storage, some of whom it will be intimate with different parts of it, but may need some introduction to carbon capture and storage. So the report does include, as it were, a high-level description of the process, and that also enabled us to describe how we had separated out the value chain into capture, transport, and storage. The analysis and reporting included a discussion within the document and allowed us to have some analysis of the responses of the people that we'd interviewed and the feedback that we got from the CCSA. So this is the next couple of slides are, as it were, the conclusions of all this work. Next slide, please. So the first thing to realize, and I have said this so many times, and I'm going to say that again, that misuse of standards I perceive as one of the biggest risks to carbon capture and storage. People think CO2 is a gas, so is natural gas. Well, we're good at natural gas, we use the same standards. And in fact, carbon dioxide is a very different gas from natural gas. And if we are tempted to use natural gas standards without knowledge of the differing properties between the two, then that is a recipe for disaster. And disasters have happened, and the Gorgon project in Australia discovered to its cost that CO2 is a very different gas. The next thing is that we are desperate for standards in some areas, and measurement and metering for the impurity content and the mass flow is frankly a gaping hole. And that's why we have got Ben speaking to us later on, because that is a gap that needs to be plugged with some urgency. We discovered that there are no real standards for leakage detection for onshore pipelines. And that's not just the physical detection, but to say what would be a permissible fugitive emission from a pipeline network. There's a hole in terms of risk management strategy for the offshore pipelines. Accidents do happen. Some pipelines fail in circumstances that may not be accidental, but we've still got to manage the strategy for the eventuality of an offshore pipeline failing somehow. We need better standards to say how much CO2 is permanently stored. The Sleipner project in Norway has done very well in computer modeling the passage of the CO2 through the geological strata, but there are no internationally agreed standards to say how it is monitored, what are the acceptable limits, and so on. And we need some standards too for assuring the long-term integrity of storage sites, which is one of the things that worries the public, and rightly so. To make this happen, we need to have closer cooperation with standards making organizations worldwide. I said before that people have already been doing this stuff. Well, we need to collaborate on what standards we've used, and that has already started to take place. We also need to increase awareness, access funding, commission research, and move swiftly, and those won't be a surprise to any of you. Next slide, please, which you'll be pleased to hear is my penultimate one. Since the report was issued, it's now accepted much more widely that that misuse of standards was a risk. I'm seeing that in the EU and further afield. In terms of monitoring metering, we've got the CNTC 474 working group, and the Energy Institute has just issued a paper on measuring impurity content. For quantification and verification, that's been picked up by the CEN Working Group 3. And there is some work looking at the long-term integrity of storage sites that is being commissioned by the Energy Institute. I'm sure there are others. Those are some that I just picked out to show that this report is being read and it is being actioned. Final slide, please. Just 3 bits here for further reading for those of you who are interested. You will get a copy of the slides after the meeting, and there are some bits and pieces there for you to pick up and read at your leisure. Thank you very much. I'd now like to hand over to, I think Ben follows me. Yeah. Thanks for your attention, and we'll pick up questions later on.
Yeah, cheers, Andy. Very good there. As I say, I've been very proud of what this report has achieved, and we couldn't have done it without your expertise and and guidance. Probably the only other thing to pick up on is that I haven't very often heard exciting adventure and standards in the same sort of sentence, so that's a good endorsement. Yeah, keen to bring in Ben. It's good to see that you've made it, because you've had a bit of stress on your end. So thank you very much. Really appreciate that you've been able to join us. So Ben is the Strategic Business Development Manager for the Energy Environment sector at NPL, the National Physical Laboratory. Over to you, Ben.
Thank you, Seb. Morning all. Thanks to the team at BSI as well for organising today's webinar. So today I'm going to be talking about the role of the National Physical Laboratory, or NPL, in supporting the deployment of carbon capture and storage, or CCS. I'm going to cover where NPL fits in the wider ecosystem, give an overview of the types of activities we're involved in, and how our work supports the development of safe, high quality and enduring solutions. But many of you probably aren't familiar with NPL, so let's start by introducing who we are and what we do. Next slide, please. So who is NPL? NPL is the UK's National Metrology Institute. We develop measurement solutions that underpin business, innovation, trade and regulation, and that's nationally and internationally. We've been around since around 1900. We're based in Teddington in southwest London, where we have about 1,200 experts across 450 laboratories. So we're a public corporation owned by the Department for Science, Innovation and Technology, and we operate as an independent and trusted advisor, working with a broad range of stakeholders. So in addition to maintaining the UK's primary measurement standards, we carry out pre-normative research. And this is the type of research that Andy's spoken about that's referenced within national and international standards bodies. It's kind of the content of those standards. So we develop new traceable methods and standards that help provide assurance, especially in areas where innovation is rapidly evolving. So these methods may go on to inform regulatory or industry standards, but in some cases, they just create a national capability that without formal publication. So the capability exists to support supply chains, but we don't formally publish a standard. And we're part of the UK's national quality infrastructure, as Seb mentioned, alongside BSI, UCAS and the Office for Product Safety and Standards. Next slide, please. So I should probably just mention the NQI, because it's a bit of an unusual framework that people reference but don't really talk too much. So the NQI is a framework that ensures regulation is enforceable, trade is fair, innovation is safe and scalable, and it gives assurance to stakeholders like regulators, investors and policymakers. So each component plays a distinct but connected role. Metrology ensures accurate and traceable measurements, standards define and agree expectation for performance and safety, testing and calibration apply standards of metrology to verify conformity, accreditation ensures confidence in all of those services and the service providers, and market surveillance kind of detects the gaps or issues that might slip through into the market. So think of it like a chain. If one link is weak, the whole system can lose trust. Now, you'll notice on the infographic that metrology sits at the base of the pyramid, and that's because it takes quite a bit of time to deliver the pre-normative research to develop these national and internationally recognised measurement standards and test methods. There's lots of intercomparisons and agreement that has to go on within international communities. We don't just dictate what is set. And that's why we begin our work well in advance of industry needs. Next slide, please. So why is NPL supporting CCS? So as the UK's National Metrology Institute, our remit is to develop the infrastructure that enables government policy, and we focus on 4 national challenge areas: prosperity, security and resilience, health and life sciences, and energy and environment. I work in the energy and environment team, and our priority is essentially to deliver the metrology needed to make the transitions to reach net zero. So we focus on areas where there's a clear demand for measurement support, and as hopefully you picked up from Andy, there's a lot of gaps that need filling to support CCS development and deployment, but also where our unique capabilities can contribute. So the current focus areas are battery supply chains, CCS, hydrogen, nuclear, the electrical grid, and solar. And rather than trying to become experts in all of these domains, we concentrate specifically on the measurement challenges. So we have to work very closely with domain experts and the types of organisations that Andy mentioned that he interviewed in his efforts. And that helps us to prioritise where we focus. So to do this, we run structured engagement exercises with industry, regulators, academia, and policymakers. Next slide, please. So the outputs from these engagements are published as energy transition reports that are available online. And there's a link to the one for carbon capture and storage in the bottom right there. I think these slides will be shared after. But this infographic is an extract from CCS, and it was, I think our energy transition report in this area was done several years ago. And it's just interesting how the priorities highlighted then are still the same as today. And those were things like measuring impurities in CO2 streams, understanding material degradation in CO2 environments, monitoring emissions from novel capture processes, and monitoring subsea emissions to verify containment. And these challenges kind of guide our capability development and research planning. So it's probably just worth remembering that MPL's work contributes to regulation, innovation, trade, and assurance. So all the different pieces of work we do has a slightly different route to impact. Next slide, please. So to give a sense of the breadth of our work that has resulted from this external engagement, this is a snapshot of who we're supporting, aligned with those different categories before. So we're supporting regulators defining measurement standards for environmental permits, site operators to measure and verify emissions so that they can participate in emissions carbon scheme, a trading scheme, technology developers to evaluate material performance and degradation, instrumentation companies to validate analytical methods, and infrastructure developers to kind of assess the corrosion rate of pipelines. So it's really about enabling the deployment, not just creating a scientific understanding. And that's the kind of the bridge in the gap between industry and academia. It's very applied. It's to build confidence in the development and deployment of these technologies. So I'll go on to talk about each of these examples in a bit further detail. Next slide, please. So regulating capture plant emissions. I talked about supporting regulators with permitting. Emissions from power and industrial plants are regulated by the Environment Agency. But with carbon capture, new emissions such as nitrosamines from amine degradation will emerge, and monitoring methods are urgently needed for the new types of permits for those site types. And without them, regulators can't assess the environmental risks of CCS integration. So MPL is developing these measurement methods along with some calibration protocols that are needed to detect those pollutants. And it's a great example of how metrology is supporting and enabling regulation, especially before the problem escalates or becomes politicized. Next slide, please. So this is verifying offshore. It should really be verifying containment for offshore storage. So obviously CCS only works if the carbon dioxide stays underground, but validated methods for detecting and quantifying subsea leakages are missing. So we're working to try and develop and validate acoustic techniques to detect, attribute, and quantify these potential leaks. And these methods could become a requirement within offshore injection permits that the NSTA are currently focusing on. And it's really to ensure that storage is not only assumed to be safe, but we can actually prove it to be. Next slide, please. So there's more about underpinning trade. So specifically focusing on the emissions trading scheme. CCS can only be included in the ETS if we can provide, or prove, should I say, how much CO2 is captured and what leaks. That's from both point sources, as we discussed with the permitting example, but also from fugitive leaks across sites, again, sort of building on what Andy said earlier. So we're trying to develop monitoring methods for leak detection and quantification of CO2 across sites of varying scale. And the intention here is to develop guidance on best available technologies, or BAT, along with kind of measurement protocols for how you apply those technologies in different operational environments. And if we can set up a quality assurance scheme around that, it will ensure that site operators can benefit from trading, but also maintain credibility and compliance. Next slide, please. So assessing capture materials. This is more about how we're supporting innovation on a different side of the type of work MPL does. So many of you will know that there's lots of new capture technologies being developed quite rapidly. These are on the lower TRL scale, so it's less on our technology deployment focus, it's more on our technology development. And capture technologies, from amines to metal oxides and membranes, each has different performance characteristics, but not many are well understood over long durations. So at MPL, we've developed a testing rig where we can simulate operational conditions, and we can study the capture efficiency, the CO2 purity, the stability, and some of the degradation byproducts from different capture materials. And we've been doing this working with some manufacturers to give them confidence, also helping them to optimize their systems and the materials they use. But another avenue here is that we kind of act as that independent third party. So we've been providing confidence to technology investors and policymakers. Next slide, please. So measuring impurities, and again, this is kind of building on a point Andy made earlier. So this example really supports both assurance and trade because they're quite interlinked. It's specifically important in the UK at the custody exchange point for carbon dioxide, or between emitters and transmission and storage companies. So there are contractual obligations to evidence the quality of the CO2 exchange from one party to another. And that's to manage the impurities in the CO2, because if you have impurities or certain impurities, they can cause or accelerate corrosion, phase change behaviors, lower energy efficiency and transport storage. But the measurement methods available are patchy, and there are limited traceable gas references that can be used. So we're developing new methods for both online and offline analysis of CO2 quality, but we're also developing the reference gases that will help validate and calibrate commercially available instrumentation. And I believe this work's already likely to inform some international documentary standards that sit with ISO. Next slide, please. So this example again is one around assurance, but to different stakeholders in the value chain. So CO2 quality specifications within different CCS schemes today, they can be considered overly cautious, and I've heard that from speaking to some stakeholders in the US who have expertise in these areas. But it's really because the true risk of corrosion from impurities is unknown, so they have to be overly conservative. What that does is it increases costs and limits flexibility of CCS schemes. So what we've been trying to do is we've established a new test facility that enables us to measure corrosion rates in dense phase CO2 environments using traceable impurities. And our aim here is really to develop new international standard test method, which will be under AMPP SC26. And that will help provide real world data for designing infrastructure and pipelines, and hopefully reduce that over-conservatism and support the successful rollout of these types of schemes as a whole. Next slide, please. So just some final thoughts. So most of the current focus in CCS is on kind of the front-end engineering design and on pilot projects. And there's been a lot of discussion around subsidy schemes, business and contractual models and mechanisms. And these are all critical, but they don't guarantee long-term success. So MPL and the wider NQI, along with BSI, we kind of play this different but essential role. We're making sure that what is built is safe, is credible, and it's future-proof. We've seen what happens in other sectors where measurement and quality are treated as afterthoughts. It leads to cost, controversy, and sometimes the collapse or demise of specific technologies. And with CCS, I think we all know that we can't afford this type of failure. Final slide, please. So thank you for your attention. I should say that the Clean Technology Programme I lead at MPL is one of our largest, and I'm supported by over 17 technical groups across 5 departments and even more subject matter experts. So much of what I've covered today is plagiarised. It's a culmination of their efforts and hard work. We have further publications on all of those topics. I've put my email address here. You're more than welcome to contact me directly for further information, or I can put you in touch with the right people for further discussions. So thank you again, and I will hand back over to Seb and look forward to the panel discussion.
Brilliant. Thank you very much, and thank you for your plagiarising there. Much appreciated. Yeah, really good explanation of the national quality infrastructure and how it supports trade, regulation, innovation, and assurance. The other thing that jumped out at me is how important measurement is, particularly for all the stuff that you mentioned, but also for accurate monitoring, measurement, and verification, which provides that safety and accuracy for carbon accounting and participation in trading markets. So yeah, really interesting there. Thank you very much. With that, I'd like to hand over to you, Beth. I can see you've turned your camera on, so great. So Beth is the head of UK policy at the Carbon Capture and Storage Association. You're right for me to hand over to you there, Beth.
Absolutely. Thanks very much, Seb. And many thanks, Seb and BSI, for having me along this morning as well. Really great to be part of this webinar on a very topical area at the moment for the CCUS sector. So this presentation will be coming from a slightly different stance from the others this morning. What we'll be doing is taking a look at the focus areas for the CCUS sector, starting globally, but then also focusing in on the UK as well. Not only looking at the current focus areas, but also what's to come. And I really hope that this reiterates and frames the importance of the items that we've just had presented by Andy and Ben in the context of how standards can be taken forward to really act as a key enabler of that successful decarbonisation of the UK's hardest to abate sectors. So before I get into the bulk of the presentation, in case you don't know us, we are the Carbon Capture and Storage Association, or the CCSA, and we are the European trade association that works on accelerating the commercial deployment of CCUS through advocacy and collaboration. Next slide, please. Many of you on this call may well be members of the CCSA, but just to give an oversight of the kind of companies that we work with, we have around 120 members now that span across the whole CCUS value chain, from transport to storage to capture, as well as working closely with EPC providers, consultancies, academic industries, and also aligning closely with regulators and with government as well to make sure that we can push forward the deployment of the sector in everybody's best interest. And next slide, please. Perfect, thank you. So I think where we'll be starting today is I wanted to give a bit of an overview of just exactly what we mean by CCUS and the CCUS value chain. I know the word value chain has been used a bit this morning to make sure we're clear on that before I delve into sort of the status of deployment across the world and the UK. So when we talk about the CCUS value chain, we are essentially talking about 4 key elements. So that is the capture of your carbon dioxide. That's typically from the hardest to abate sectors. So that could be things such as your industrial activity. We've already had references to cement, to steel, to chemicals. But that also includes power generation. As many of you may be aware, we've got the Clean Power 2030 programme active in the UK at the moment. So looking at things like low carbon dispatchable power, whether that's gas CCS or hydrogen to power, to balance an increasingly intermittent grid and really enable and promote that further rollout of renewables as well through that complementing generation. It also includes things such as hydrogen production, so looking at blue or CCS enabled hydrogen, and also negative emission sources as well. So that's your power BECCS or bioenergy sources, as well as direct air capture, which we refer to as DACs. So that's just the first element of the value chain. And then what we consider is the transportation of that CO2 in the early stages in the UK at the moment, typically through pipeline, but also exploring non-pipeline transport methods such as by ship, road and rail. And then it's either your storage of your CO2, so permanent storage in deep geological formations underneath the seabed is how we store it in the UK, or the use of CO2. So that's referred to as a CCU or carbon capture and utilization. And sometimes CO2 can be stored in products for that circular economy aspect, or for sites that might not yet have connection to a transport and storage network. So I hope all of that is clearly represented in the figure on the right-hand side, and I think it's worth noting that when we're talking about a CCUS cluster, what we are really referring to is all of these different applications of CCUS technologies that are co-located, so they're deployed at sites in proximal geographical locations that can then come together, take advantage of economies of scale by sharing that CO2 transport and storage network. So as we move through, as we're referring to a CCUS value chain and a CCUS cluster, this is the concept against which we're talking about and working on. Next slide, please. Brilliant, thank you. So if we look at international activity, it's really safe to say that we have seen some strong progress in the CCUS sector over the last few years and especially over the last year as well. So this data is taken from the Global CCS Institute's status report. One of these comes out each year. And I think some really important and eye-catching statistics from 2024's report is that what we've seen is a 60% year-on-year increase in CCUS project development, with a total of 50 projects now operating globally. I think on the policy side, it's also worth noting that what we've seen is over 50 bilateral agreements that have been executed by national governments that include CCS within their scope. And I think just noting this international collaboration on working towards CCS solutions is one worth keeping in mind for later as we talk about the role of standards in enabling deployment. Next slide, please. And then finally, to set the global scene, something that I wanted to bring to your attention was the development of transport and storage, or TNS networks, which I alluded to on the initial slide. So what we have seen is that this ongoing development of shared CCS networks has resulted in what we could call a new industry category of CO2 transport and storage, or as we refer to them, TNS facilities, representing this industry model for CCUS that's not purely defined by capture source. This is very much how the UK has been developing its first projects, as have many others around the world. So again, I just wanted to raise this at the beginning of the presentation so that we can keep it in mind as we move through and think about the role of standards in enabling this. Next slide, please. Excellent. So what I'm going to move on to now is looking at the UK focus for CCUS, and specifically this focus around the policy and political framing before we go into some of the applications in more detail. So I think to start from the beginning, it's we look at what we call the CCUS vision in the UK. Now, underpinning the sector's deployment in the UK is this document, or this CCUS vision. This is a publication that we saw in 2023 under the previous government, and essentially it sets out how CCUS will support the UK's net zero ambitions through the development of a commercial and a competitive CCUS market. This, as I said, this vision was published under the previous government, December 2023, and it sets out the details to a self-sustaining market in terms of 3 phases, and that is something that the sector is still very much working towards. What you can see on the left-hand side of this slide are those phases. So phase 1 is very much the phase that we're in now, which is what we're coining the market creation phase. Phase 2, the market transition. So how do we start to see the emergence of a commercial and a competitive market as we approach 2030 and beyond? And then as we transition beyond 2035 towards 2050, it's reaching that self-sustaining market. So what do we need to see in terms of that policy certainty, policy development, and that shift in sort of technical developments alongside the role of both government and private investment into pushing this market towards one that is competitive, self-sustaining, and allowing not only the UK but the rest of the world to meet decarbonisation targets as well where it is deployed. Next slide, please. Excellent. So that was something that was set under the previous government. I think what's clear is that the CCUS sector, and as alluded to by both Andy and Ben as well, is a very fast-moving sector. What this slide does is it acts to summarise, not exhaustively I would add, but it acts to summarise some of the key developments that we have seen since the change of government. So this is since last summer. One of the ones that some of the themes that I'd like to pick out is around clean power. So we saw last summer the launch of NESO, of Clean Power 2030 plans, and then also mission control as well. So there is a real focus on that. And I think that theme for clean power is something that we saw reiterated during last week's spending review as well, and the role of energy security in national security, so definitely worth keeping in mind. Also the role of public financing, so we've seen both the launch of GB Energy and then also the creation of the National Wealth Fund as well, so understanding how they could be vessels into funding CCUS projects and playing that role in the initial scale up to lead to cost reductions and commercial deployment over time. And then also Invest 2035, so this is the prelude to the industrial strategy, which we are actually expecting very shortly. So a real focus on homegrown clean industry and growth, and looking at maintaining the industrialisation of the UK economy and decarbonising it on home soil. That's very much the first half of this slide in terms of some of the policy developments and focus areas. But I would also like to draw your attention to some of the physical key project milestones that we have seen in the sector as well. Firstly, back in October, we saw the current government reaffirm the commitment to fund the first CCUS projects, or to provide funding. So that was, as Seb introduced earlier this morning, the 21.7 billion of funding committed to those first two CCUS clusters. Between then and now, we've also seen some really exciting updates. We've seen Net Zero Teesside Power and Northern Endurance Partnership reach financial close and move into the execution phase. So that's in the East Coast cluster in the northeast of England. We also then saw earlier this year ENI reaching financial close for the Liverpool Bay CCS project, as the North Sea Transition Authority, the NSTA, awarded the storage permits for that project. Moving on, and then much more recently, just last week, we saw that within the comprehensive spending review, 9.4 billion of funding over the spending review period was allocated. So that was for two key things. That was to maximise the build out of the HyNet and the East Coast cluster, but also to progress the Acorn project and Viking CCS as well. Again, building on comments from earlier this morning, these are very promising signals for the sectors. It's great news and sort of a significant milestone for CCUS in the UK, as well as looking at it in terms of your regional decarbonisation, the growth that comes along with that, as well as really important elements such as job creation and job retention as well. Next slide, please. Thank you. And then I suppose bringing all of this together, what does this actually look like in terms of the status of UK CCUS? So I think Andy actually had a very similar slide up earlier, but looking across the UK, so what do we have at the moment? We actually have 13 CCUS clusters, the ones that we've talked about already in the previous slide. So you've got HyNet and East Coast Cluster, which were termed Track 1 under the UK's cluster programme. We've also got the Viking and the Acorn cluster, so that was termed Track 2 under the UK's cluster programme. So together, those would be looking at providing decarbonisation solutions via CCUS cluster approaches to the northwest of England, as well as the north of Wales, in Teesside, in the Humber, and also up in Grangemouth in Scotland as well. On the left-hand side of this slide, this is available on the CCSA website. I've put the link in this slide so you'll be able to access it when the slides are circulated after. But this is the CCSA's capture map. This has data that we have acquired from some of the UK's projects, and it includes elements such as the application of CCS, volumes, target dates, and sort of key policy areas as well. It's quite an quite useful interactive tool, so if anybody has any questions on that or would like to use that resource, please feel free. And all of this information is available for your reference on the CCSA's website. Next slide, please. Great. So the last section that I wanted to move on to is the focus areas and applications to really nail down and frame this need for standardization. We've talked about the policy and the political backdrop as well as the global status, but actually in the UK, what are we really targeting and what are the priorities for the sector at the moment? The first slide that I wanted to include on this is looking at the storage element of the value chain. A key focus, obviously, to ensure that we have sufficient storage capacity to meet ambitions for carbon capture and storage volumes within the UK's plans. What I think is important to reiterate is that the UK has a really unique advantage in CO2 storage. Again, I think it was Seb that mentioned it's an estimated 78 gigatons of storage capacity under UK waters, which represents a third of Europe's geological storage. So there's a real opportunity here, not only to meet UK ambitions, but to remove barriers to enable a European-wide CO2 storage market and allow the UK to also export its plentiful storage capacity, but also its expertise in the North Sea, which is sort of very geographically specific, but also allows us to continue that skills base that we've built through years of oil and gas operations as well, and repurpose that towards CCUS. If you would like to learn more about this topic and accelerating the European-wide CO2 storage market, I've included a QR code in the top of this slide. That should take you straight to the download link for this paper, which is open access, and it can also be accessed on our website as well. So please feel free to take a look through that, and that includes sort of a series of recommendations, challenges and opportunities as well relating to unlocking this opportunity, both from a regulatory but also a technical perspective. Next slide, please. Carrying on with the focus areas, I think probably three core ones on the capture and transport side to bring your attention to is infrastructure, industry and power. So over the course of the last, I'd say probably the last 10 months or so, there's been several opportunities that the CCSA, along with its member base, and I'm sure some on this call as well, have been feeding into really shaping the policy development in these areas and allowing sort of the full opportunity that and benefits that the UK can offer to be realised. What we've seen is the long-term infrastructure strategy working paper. I believe actually we're due to see the infrastructure strategy published very imminently. So looking at the infrastructure needs and requirements for the sector and the long-term role of this over the next decade or so. Moving on, looking at the industrial strategy and sector plans within. Cement for steel, looking at sort of embedded clean energy sector plans, really bringing all of that together and understanding that cross-cutting role that CCUS can play across many areas of the UK's modern industrial strategy. And then also clean power by 2030 as well. So we saw the NESO published their advice on CP 2030 last year, followed by the government's action plan. And it was stated that 2 to 7 gigawatts of low carbon dispatchable power, so that would include your power CCS and your hydrogen to power, would be needed to meet these targets, which again is a very positive signal for the sector and one that the sector is working towards fulfilling. I think, again, just to reiterate what was very clear from the spending review last week, was that there was a clear focus on the role that CCUS can play in enabling energy security, clean power and national security. So interesting to have that policy framing as we work our way through some of these priorities over the coming weeks and months. And next slide, please. And the final focus area I wanted to bring your attention to is looking at negative emissions. So largely what we've spoken about today is the role of CCS in decarbonising these hardest to abate sectors within the UK. But I think it's also worth reiterating that in the 7th Carbon Budget Advice published by the Climate Change Committee earlier this year, there was a clear need as well for engineered CO2 removals to offset the remaining residual emissions after you've reduced emissions and then decarbonised the hardest to abate or process emissions via CCS. In that report, there was a modelled 35.8 megatons a year of engineered removals required by 2050 to meet this and to offset those residual emissions. It's also worth noting that in the UK, it's currently targeting at least 5 megatons of engineered removals by 2030, increasing up to 23 megatons by 2035. So clear signals there and a clear role of GGRs in also scaling up the deployment of the wider CCS sector, reducing that first of a kind risk and bringing down costs through time. And just to be clear, when we're talking about engineered removals, this can include things like your power BECCS, so your bioenergy with CCS, which obviously has the benefit of providing net negative power as a co-product, as does energy from waste and direct air capture with CCS as well, or DACs. And next slide, please. Thank you. And this is my last slide, which is much of this we've been focusing on what we've seen over the last year, but actually what's next for the sector. There's a lot of momentum behind the CCS sector at the moment, and we certainly have a busy summer coming up in the UK. What we're expecting over the next few weeks is the 10-year infrastructure strategy, the industrial strategy, the trade strategy, as well as sector plans for things such as advanced manufacturing and clean energy industries. I think later this year we are expecting updates to market and refreshes on the hydrogen strategy, and then all of this will be supplemented by the carbon budget delivery plan and also a post-16 education and skills strategy as well. The reason I wanted to bring this slide up is just really to reiterate all of these different focus areas for CCS and how it cross-cuts so many aspects of the UK's economy. And then I suppose my key take home for this presentation and for this slide as well is that bringing all of this together, not just globally, but especially within the UK, we have a very unique and substantial CCS opportunity. It offers a essential decarbonisation solution across the hardest to abate sectors, but also to tackle those residual emissions as well. I think, therefore, that cross-cutting element of CCUS across several sectors of the UK's economy really reiterates that standards will provide the cohesion and alignment that we need to allow the safe, cost-efficient and scaled-up deployment of CCS, not just across the various aspects of the value chain that we looked at to start the presentation, but also across the various aspects of the economy as well as it moves towards a decarbonised and net zero system. And I think on the next slide, that's everything from me. I've put my email address here if you've got any questions at all, along with the CCSA website where we keep a lot of our resources. So please do feel free to reach out, and happy to cover any questions later in the session as well.
Brilliant. Thank you very much, Beth. There's a lot that sort of jumps out there. I thought the CCS value chain, I love the infographics. I might have to take a leaf out of Ben's books and plagiarize that from you guys. That looked really good. And yeah, a lot of strategies coming up. The thing that also blows my mind, and I sort of knew this, but it also blows my mind that, there's a pipeline of 628 projects. I always find it quite impressive. And I always forget how large scale this is. I think with that, thank you, Beth. I think our formal presentations are now over, so we can move to the panel session, which is on the screen. So can I ask all the panelists to turn on their cameras? And for the audience, please post any questions and or observations to the panel so that I can put those to the panel. We're probably aiming for about 20 minutes or so, so let me set a timer to make sure that I'm on time. There we go. So thank you for that. It was really, really insightful, really useful. Beth, I've got a question for you. Apart from standards, do you see that there are any other sort of challenges or bottlenecks that might be sort of slightly holding back the deployment? It seems like there's been a lot of commitment there now. It seems we have a long-term certainty, which I think is always sort of welcome. Is there anything that you think is still standing in the way?
Yeah, no, that's a really good question. I suppose several angles you could come at this question from. I think probably unsurprisingly and very predictably from me, I will stick on sort of the policy and regulatory side of this and potentially hand over to the other speakers on any sort of additional technical challenges they see. But something that I would really, really like to reiterate is that CCUS projects are long-term projects. Because of the long-term nature of them, it is really important that we see that stable and that predictable policy environment to attract the private investment, and that private investment may be something that, to build on my presentation, is really a prerequisite of allowing that CCUS vision ask to transition to that self-sustaining market. I think without it, what we could see is that capital could go elsewhere. We've seen countries such as Norway are moving fast, and just this week we saw the launch of the Longship CCS project as well in Norway. So policy clarity is really crucial for businesses to build these, or to commit to building these multi-decade projects. And as we said last week's spending review exercise in the UK is really great progress towards this, and really reaffirms how the UK is taking this forward. So I think probably that the take home from me is that a stable policy environment is that bedrock of clean growth. I suppose to build on it, what exactly do I mean by policy clarity or policy stability? I think at the high level, encompassing actually everything, it's that need for clarity on funding commitments, on deployment targets, and indicative timelines as well. By having the clarity on that, what it allows is for the supply chain to be mobilized, directed, and then projects to become operational. And I think the importance that there's no pause, there needs to be that continual signal to investors that CCUS is at the heart of the UK's approach to decarbonisation, and enabling our low carbon future as well. And again, I think the spending review has been very good at fulfilling this. I think that's probably in terms of the challenge, but I suppose where a bottleneck could arise is if we were expected to build sort of a lot of CCS projects at the last hour or sort of last minute prior to net zero, or to sort of fulfill respective government corporate targets. And then that's when you can start to experience that shortfall or that bottleneck on sort of diverting skilled people and manufacturing to those projects that need to deploy. So really the best way that you can deliver those safe, cost-effective projects at the volume required to meet these targets is to be very clear on that pathway, and to continue to be clear on that pathway. So obviously we've seen the spending review, which is great progress, and it's just that continued momentum and policy direction through these strategies that we're expecting as well, to make sure we continue that push forward and sort of recognise that long-term nature of these projects as the solutions.
Yeah, no, thank you for that. And that's an interesting one. One of the reasons why we sort of did the standards roadmap when we did it was also the recognition of the earlier you can deploy CCUS, the more impactful it will be on the transition to net zero, right? And long-term policy stability, that's something that, you know, in all the areas that I've worked in, we sort of always sort of ask for. I think, you know, it gives this geopolitically, thankfully, there's a lot of certainty, insert sarcastic quote, but yeah, there's obviously geopolitically, it's very interesting how the environmental agenda is sort of shaping up. But I think, you know, the CCUS agenda here seems to have that long-term commitment. I don't know if anyone else wanted to come in, Andy or Ben. Don't worry if not. Nope. Brilliant. Andy, a quick question for you. What are some of the lessons that the UK can learn from CCUS leaders such as Norway, or, you know, some of the work that's going on in the US? Is there anything else that you think we can learn from other countries?
I think there is enormous potential for international collaboration between countries. CCS is not a problem, rather the global impact of CO2 is not a problem for the UK, it's a problem for the globe. This is a problem that we need to solve together. We need to pool resources, we need to share information. And I realize that a lot of this information is generated by commercial organizations, and that they like to keep the results confidential. I understand that, but at the same time, if somebody comes up with a solution to a problem, the beneficiaries are you and me and the rest of the world. Now, BSI, I know, has already established a liaison with China so that we can each tap into each other's knowledge base. But I think there are lessons from every project everywhere in the world. I suspect it's got something to teach the rest of us about it. So I'm all for sharing the information for the benefit of humanity. I don't know if anybody else would like to.
Yeah, that's a really interesting point. I said that's a really interesting point, and I always think there's something about the international standards infrastructure. You know, ISO in particular is in 164 countries from top of my head, maybe more, right? And it is an old infrastructure. It's got its benefits and sort of drawbacks, but I do think there is something more there that can be done rather than, you know, shall I say, only standards creation. That there's also something about knowledge sharing, because you know you have such a sort of wide platform there. Yeah, that's really, really interesting. And I can only agree with that. Does anyone else want to come in on that? Don't worry if not. Ben.
I can. Yeah, I mean, metrology is very niche, so I always have to kind of caveat what I say with, my exposure to the sector is limited from my worldview. But I do feel that there could be improvements with the linking between kind of policy, infrastructure planning, and standardization to kind of integrate the measurements, science, and verification frameworks into CCS from the outset rather than retrofit later. And I'm not sure what how good overseas countries have been doing that, but a lot of the standards we're looking at would be international or European, like CEN or ISO anyway. So it appears that it's a similar issue overseas and not just in the US, because they don't exist there, similar to being unavailable here.
Yes, no, thank you. That's a great point. I've got another sort of question for you. Do you see that there are any sort of opportunities, maybe sort of more from a metrology point of view, for impact in enabling the deployment more, to have more impact? Is there anything that you've seen from your area that you say, actually, that's where we can really have impact? That could be one of those sort of dominoes that we can knock over, that'd be really beneficial for industry.
Yeah, I also think it kind of answers one of the questions in the chat from Abby. A lot of people are building the infrastructure around modelled and theoretical scenarios, and it kind of ties into one of the slides I talked about, where there's quite a lot of caution and over conservatism in how things are handled and managed, which adds cost to the overall scheme. And I think if you invest in the data, what impurities really have to be filtered out of the system, because those are a combination of those are actually going to degrade the infrastructure. Once you start getting a true understanding of that, you can be a bit more flexible in terms of your specifications and a bit more confident that the infrastructure can handle it, especially when you remember some of this infrastructure is repurposed, so it's not new, purpose built. We need to have confidence that in the system. And so I think that's what I'm seeing a lot of. We're being approached by unusual methodologies. I expect a lot of this type of research to be funded via Horizon programs and stuff like this, but actually industry are coming together now and setting up joint industry programs and stuff to really fill in some of those gaps, because it is so critical to have that data and that confidence to reduce some of the specifications and enable more flexible solutions.
Yeah, really interesting. And I always wonder, and again, like you come in from your metrology head, I always come in from the sort of standards angle. Standards are a number of things, right? And it could be guides on good practice. And I always feel there's something there to sort of capture good practice as it's sort of emerging, and capture that and sort of share that more broadly, because in some sort of new areas, actually, we don't know how to do it. And having sort of that guidance could be useful. Yes, it might be out of date in 2 years, but that's okay at this stage, right? So I always feel that there's more there. I noticed some questions from the audience, so let me take a few of those. There's a question which I think is for me. Any plans for a companion study for, say, hydrogen cross-sector standards lineup? Yes and no. So yes, I would be very keen on sort of doing that. So I'll take that away. This was a self-funded piece of work at BSI, so I had to go through a few sort of hoops. But I think it's one that I'm very keen on. We've done a lot of work in the hydrogen space, both on the formal standardization work, but also on the fast track standards, supporting hydrogen for heat trials and the PASS 444 series that people might be aware of. And I think it's something we should do. So let me take that as an action, but I can't promise it because obviously it is internally funded. Here's a question for you, and I don't know if you can answer this, Andy, but there's a question here. Can I ask you why you didn't approach DNV? Now, I don't know if that sits with you or me, because when we designed it at first, we looked at sort of stakeholders, but see how you get on, I suppose.
No, it was. I was part of the selection process for these people. Ringing somebody up and saying, can I have an hour of your time or a couple of hours of your time, and would you like to fill in this questionnaire? is not the sort of telephone call that a lot of people will welcome.
Yes.
So the people we selected were people that I knew personally, who would be prepared to, as it were, do me a favor and stick with me and talk about things and answer questions. And as it happens, I didn't have, as it were, a friend in DNV that I could presume upon to be a part of the survey. With the benefit of hindsight and with the availability of a suitable contact, DNV would have been an excellent set of a company to approach. But in the event, I didn't have the contacts.
Yeah, and it's also the reality of doing these things. You sort of sketched out this sort of overview of thousands and thousands of standards and all the work. And, as you say, it's sort of an elephant you can only eat one bite at a time. In retrospect, there's always stuff that you can do, but even setting up all the meetings and all of that took such a long time to sort of coordinate all of that. So, yeah, in retrospect, it would have been great to have them very much on board. And maybe that's there's a phase two or something we should look at.
Yes.
There's a question here. There's a question here, so let's see if who wants to sort of stick their hands up. Given the diversity of the CO2 sources, how do we develop flexible yet robust specifications that do not put extra cost, high energy demand, and challenges on capture technologies? I don't know if anyone wants to answer that sort of very easy question.
Oh, I'd love to. We develop standards have been developed for the impurity specification with the CO2 with the objective of engineering our way around 4 particular problems. One of them is corrosion in carbon steel pipelines. Another one is to avoid the unwanted mechanical properties, effects that the properties of the CO2 imply. And for those who understand, that's running ductile fracture. Another one is to avoid rapid phase changes in the CO2. And for those people who understand it, this is moving very rapidly from gas phase into the 2-phase area and then into the dense phase area, where you can get density changes of several orders of magnitude, and that gives you control problems. And the fourth one is to avoid degradation of the straw structure, such as degrading of the caprock. And we've set the specification has been set specifically to avoid those 4 things. And if anybody, the idea is that anybody can put their CO2 into the system, and at any point in the system, in the network, we can give the guarantees that those 4 phenomena will be avoided. And that means that everybody has to produce their CO2 to quite a high standard. Yes, it is possible if you've got somebody with extremely pure CO2 to admix in with that some very impure CO2, but that leaves you a hostage to fortune, because if the very pure CO2 person gets a plant trip or shuts down for an outage or something, it means that the very impure CO2 person becomes constrained off, and that will reduce operational flexibility. And so you end up with quite a high standard, but provided everybody can achieve that, then you end up with a very flexible system. And yes, it is sometimes achieving that, for instance, from steel, will be expensive, but we're not governed just by the commercial realities. We're governed by the chemical and thermodynamic properties of impure CO2.
Yeah, brilliant. Thank you very much. Definitely couldn't have answered that question. So, thank you. There's another question on the contracts for a different role. And I don't know if that's one for you, Beth, but could you please share your thoughts on the role of CFD contracts in the carbon capture and storage sector? Any thoughts on that?
Yeah, of course, can certainly take that one. I think this question, I'd frame it by linking back to the point I made previously about CCS being long-term projects. So what we have in the UK is underneath kind of the overarching policy and funding certainty I mentioned, there's a series of sort of business models split out by transport and storage, but also by capture type as well. So we have a business model designed for industrial carbon capture, for energy from waste, for dispatchable power, also looking at the development of greenhouse gas removals and power-BECCS business models as well. So a whole suite of these business models, and they really are based around a CFD principle, which is not a new principle in itself. It's new for CCS, but it's sort of built upon the lessons that we know from offshore wind, for example, which has seen the successful use of a contracts for difference to bring down that strike price over time. So what I would say is that CCUS, it's not a new technology, but it is a new market in the UK. Because it's a new market, it's dependent on a range of other emerging external factors as well, such as the UK emissions trading scheme over time. How will that develop as we look at alignment and potential linkage with the EU as well? So while some of those market dynamics and market principles are still in their infancy, what we need is that certainty now, so that it encourages the inward and private investment into getting the projects ready to run, by having that sort of long-term view over the revenues that could be expected over that longer lifetime of the project. I think the CFD, in terms of getting the market up and running and scaled up, is hugely important. But what I would flag is that the role of government in that CFD, so the contract between your government and your project, with the LCCC as sort of the middle party, that role is likely to change from government over time. So I think as those market dynamics mature, as I said, things such as the ETS price, which is likely to rise over time in line with net zero ambitions, but also as we see the development of things such as a private insurance market, for example. So as we see more CCS projects deploy, more technical data, real life data coming out of those projects that the private and insurance community can use to model these products, actually the need for government to step in through those business models should decrease over time. And then you start to get to that world towards the self-sustaining market. So I think absolutely critical in terms of this in the UK anyway, this initial market creation and transition phase, and then that role will naturally change as the market grows, we get more data, and the community actually involved in CCS really matures and diversifies.
Yes, no, that is great. Thank you. And yeah, really interesting. And just for people, the LCCC is the Low Carbon Contracts Company who runs the CFD auctions, right? Yeah, and it has a sort of big role to play. There's one other question. Would it be and we're sort of getting there for time. And there's probably one other question I want to ask. Would it be possible to give an idea about CCS and CCSU projects worldwide, specifically in the MENA region? MENA, I assume, means Middle East and North Africa. I don't know if anyone has any sort of knowledge of that.
I can probably provide a high level comment. It's not a region that I work closely in. I focus largely on the UK and Europe, but I think it's safe to say in terms of the regions that we are seeing the fast sort of uptick in the project pipeline and project deployment, the Middle East is really a front runner in that at the moment. What we are seeing is spades in the ground projects getting built, and projects getting built quickly to that matter. So again, I think in terms of considering that that supply chain and the skills base for actually seeing projects being built, we can talk about the concepts, but they ultimately need to get the go-ahead, need to be in construction. So that is an area where we are seeing some of that supply chain going to. There are the clear signals there, and one to consider as sort of the regions surrounding it are also looking to deploy as well.
Brilliant, thank you.
I popped a link into the chat to point people towards the Global CCS Institute, who have a database of carbon capture and storage projects.
That'll be really good. We'll share that as well. And I've got one final sort of concluding question, which is one on community engagement. We do a lot of work in biodiversity, nature markets, do the other sort of part of removing emissions, and community engagement is sort of very important there. From a CCS point of view, Andy, it might be sort of useful to ask you and see if anyone else has any sort of thoughts on that, but how important is community engagement for CCUS projects, and what does meaningful community engagement look like?
Yeah, that's a very good question. I cannot underemphasize the importance of engaging the community at just about every level within CCS. There's a lot of misunderstanding about what CCS involves. There's a lot of misunderstanding about how the CO2 is stored. And yet people are actually quite interested to hear what's going on. The CCSA has got lots of resources that people can access to assist them in this. But community engagement, if we don't have the support of the public with us, then projects just don't happen. But what is going on out there is good. And a lot of it is coming from the children at school. They will come home and they will say, we've learnt about this at school. Can you tell us more? And it's important that the resources are out there to educate mums and dads and school kids as well in what this means. And it's not. We will always get some resistance from people who don't like change. We accept that. But what we can do by community engagement is we can allay people's concerns and communicate that we are a responsible community with very good objectives at heart. So yeah, take every opportunity possible, and I know that the CCSA does.
So fantastic. No, thank you for that. I definitely wanted to ask that question, and I do feel a bit sorry now because my 8 and 10-year-old that will come home later today will get a CCUS lesson from me. So I'll start them young. Beth, did you have any sort of thoughts on that?
Yeah, no, thanks, Seb and Andy. I'd completely agree with everything Andy said, and that we can't emphasize that element enough. I think, Andy, you've done it justice. Maybe the only thing I would add is that ultimately, why are we doing CCS? So sort of throughout my presentation, there was a few things about regional benefits, growth, jobs. Those are all those amazing opportunities that come alongside the deployment of this technology. But ultimately, if we boil it down, the reason that we are doing it is that it is firmly rooted in science that if we are to meet net zero by 2050, we cannot get there without CCS. So I think when we're having these conversations, it's great to relay those benefits, but we need to make sure that we are really underpinning and reiterating that we are doing this out of climate necessity, and the rest of it sort of follows after. So I think rooting that climate element, the climate benefit, and instilling that sort of throughout the whole system, from schools to universities through to employment as well, and just making sure that that message is very clear.
Brilliant, thank you for that. Do you have any thoughts on that, Ben?
Just to echo what Beth and Andy said, really, I think it's fairly critical, and not just from a kind of permission context, but from a trust point of view. So you need to engage with them early, be transparent, and also kind of tie it into the clear sort of local benefits like jobs and investment, as Beth says, and the kind of bigger mission that this is working towards, and how that's beneficial to the country.
No, that's fantastic. I think we've gone slightly over time, so I'm a terrible sort of host here. So I think we'll look to sort of conclude it there. I hope that was useful and insightful to the audience. I want to thank you all of the panelists for a great session today. I think you've really outlined the challenges and opportunities and really explained the work that we did on the sort of roadmap, and I certainly learned a lot. I also want to thank you, the audience, for a great session. Thank you for your participation and for your questions. We will follow up with audience members with an email containing a recording of today's session and with the relevant links. So we'll conclude there. Thank you very much for your time.
Thank you.
Thank you.
Thank you.